Today we're going to discuss another tool used in machine learning, and that tool is called random forest. The file that I gave you has some links that you can open and to give you an introduction to random forest. Okay, we will not go there anymore. I leave that to you for your perusal. Okay, so these are, let me just show this, for example, this one. This last link. Okay, so this is, it's a good article, Seeing the Forest of the Trees, an Introduction to Random Forest. Okay, so let's just quickly read through some of the items here. Random forests are pretty neat. They leverage on some learning to use what are typically considered to be weak learners. Okay, so decision trees, we have learned that we can make use of decision trees to predict values. Okay, and there are some weaknesses as regards decision trees, and the random forest improves on that weakness of decision trees in order to create a stronger and more robust modeling method. So the random forest is far more powerful and more robust than decision trees. Okay, so random forests are actually, wait, let me just increase the, okay. Random forests are actually, they are multi-decision trees. Okay, so you have a decision tree, and then random forest is actually a manifold decision trees, 500, even 1,000 decision trees. So that makes it, it's an aggregated decision trees. So that makes the model, the tool, random forest, more robust and a lot better than decision trees. Okay, so for example, take a look at this one. This is our training data. Then what we do is to split the data. Again, we do resampling using bootstrapping. We use bootstrapping here. And then for this, for example, for this resampled data, we come up with our decision tree. And then another resampled data, we come up with our decision tree, etc., etc., etc. And there can be thousands, hundreds of these decision trees. Okay, unlike in a decision tree, you only have one. For a random forest, you have several decision trees. Okay, so it's a manifold decision tree. Okay, so I leave you guys to read this. Now there are some let me say measures or okay. Okay. Sorry. All right. This term is also important. OOB, the out of bag. Okay. Ano yung mga out of bag? Okay. From experience, guys, from research, bagging effectively causes about 1/3 of the original data to be excluded. So when you bag, when you do bootstrapping, when you do resampling via bootstrapping, the estimate is that around 1/3 of the original training data is excluded. So hindi siya nasasama dun sa bagging. So what is done is that this excluded data, which is referred to as the out-of-bag observations, ito yung ginagamit na testing. Okay, so It's used to test the model, and estimates are determined, and then so nakakapag-create tayo ng ng computation ng errors, no? Balik dun sa natin sa confusion matrix, no? Dun sa out of bag data natin. So again guys, ang out of bag lang naman yung hindi nasasama dun sa pag re-sample natin yung data. Okay, and then also random forest allows us to measure yung importance ng variable. Okay, we'll have an example of this later on. So there's this measure called mini decrease Gini. Okay, iba to dun sa Gini coefficient, ha? Okay, iba to dun sa economics na ginagamit na Gini coefficient. Okay, so let's continue now. You can, of course, you can read on this, and there are so many other references that you can use. So again, guys, random forest is a flexible, easy to use machine learning algorithm. Okay, it produces a great result most of the time. It's also one of the most used algorithm because of its simplicity and diversity. Okay, so pwede siyang, remember yung CART, guys, classification and regression. Okay, it can be used, random forest can be used whether you want to do classification or you want to use regression. Anong difference nito? Remember, guys, pag classification, your dependent variable is a categorical variable. On the other hand, kapag regression, your variable is a continuous variable. So let's take a look at some features. As I mentioned a while ago, a random forest is an aggregation of decision trees. Okay, it can be used whether your purpose is classification or regression, and it helps to avoid overfitting. Ano ba yung overfitting? Remember, overfitting, we mean that we create a model based on the data that's available. Okay, we said that it's good to split your data, to resample your data. Okay, and then there are several ways to resample your data. We learned about that, yung training and training and testing, split the data into two. Or we learned also the leave one out, cross-validation. You have also k-fold cross-validation, or the repeated cross-validation, and you have the bootstrap, no? Yung bootstrapping. Sa bootstrapping kasi, guys, ito yung with replacement, no? Pag sinabing with replacement, you get one data, okay, and then you can put it back. So it means that one data, one observation can be chosen several times. Unlike yung without replacement, ibig sabihin pag kinuha mo yung data na yun, hindi na siya pwedeng ibalik dun sa pool ng data. Okay, so it can deal with a large number of variables. One good thing about random forest, kahit na napakaraming variables yan, kaya niya, no? And it helps with feature selection. Ano ibig sabihin nito? Ibig sabihin, it helps with selecting which variables will help predict your variable of interest best. That's what we mean by feature selection. Okay, sa random forest, makikita natin, meron tayong output na we can see if this variable is removed, what will happen to the accuracy. Okay, so we will see that in a while. Okay, and as I said, guys, it's very user friendly. It only deals with three parameters. Itong kagandahan, guys, sa random forest, dalawa lang yung parameters na tinitingnan natin. Ito yung number one, yung how many trees do we want? How many trees do we want to model our variables to create your model? So the default is 500 decision trees, but of course you can create 300 decision trees, 1,000 decision trees. It depends. Pero pwede natin malaman kung anong maganda na decision tree. Okay, and then the variables are randomly sampled at each split. So ano ba yung split, guys? Di ba yung nag-create tayo ng nodes to split your decisions, no? So yung nodes na yan, it will of course depend on the variables. Okay, so ang parameter natin dyan yung m-try. M-try refers to the number of variables, okay, at each node. Ang default is square root of p. Ilang variables ang gagamitin at each node? It's the square root of p, where p stands for your number of variables. So for example, if you have let's say 16 variables, no? Pag 16 variables natin, so ang mangyayari yung m-try natin, yung number of variables per node, okay, will be square root of 16. So that's 4. Okay, mamaya makikita natin to, no? That's for classification. Pero pag regression, it's p over 3. So you first divide 16 divided by 3. Okay, 16 divided by 3, that's around ilan yun? Mga 5, no? So around 5. Okay? All right. So steps, ano ba yung steps pag nag-create ng random forest? Okay, first we draw the number of trees, entries from the bootstrap samples. Ibig sabihin, mag-create tayo ng bootstrapping. Okay, for each bootstrap sample, grow unpruned tree by choosing the best split based on random sample of n-try predictors at each node. So medyo nakakalito yung yung explanation. So this is actually m-try, no? Just to be consistent sa ginamit natin dito, no? M-try. Okay, well, but in others they use n-try, no? Sa iba naman m-try. And then predict the new data using the majority votes for classification and average for regression based on the n3 trees. Okay, so medyo nakakalito siya, guys. Ang hirap intindihin kapag ganyan lang na verbal. But let's practice this. Let's do this and see what the random forest does. Okay, so here you have our data, and then let's view our data. Okay, paki-chat nga, guys, kung na-view na, kung meron na tayong data. Okay, thank you. All right. Sige, thank you. Okay, so may I ask you guys, did we meet this data before, itong cartographic data na to? I'm not sure kung sa class, I'm sorry, no? I'm not sure kung sa class nyo or sa other class ko nagamit itong data na to. Have we met this, guys? Ang importante dito, itong dependent variable natin yung dulo, yung NSP, no? Yung normal, yung suspect, at saka pathogenic. This is a measure of the yung heart rate ng fetus sa siyempre sa womb ng isang mother, no? Okay, so there are several variables here, and what we would want is to determine whether yung fetus, guys, whether it's yung heart rate non normal, suspect, or pathologic, no? Okay, so that's what we want. We have 3 levels here. 1 is normal, okay, 2 is suspect, number 3 is pathologic. Ito yung classifications na binigay ng mga doktor, no? 2,126 observations. May I ask you guys if we have met this data before? Na-meet na ba natin itong data na to in this class? Hello? Familiar na ba sa atin itong data na to? Hesed? Have you seen this data before? Have we used this in class? Hesed, John, or Nick? Check pa? Okay, sige. Alright. So, ito yung data na gagamitin natin for this random forest. Okay, so what we want to predict is the yung heart condition, no? Whether it's normal, suspect, or pathologic. There are different ways to do this. You can, of course, use decision tree. Okay, I would that you try to practice on this and use decision tree to predict yung output natin, yung outcome variable na NSP. Okay, but for today, we're going to make use of random forest. And if you take a look at the structure of our data, structure muna natin, STR natin, of data, let's see. Okay, ito yung NSP natin. This is the variable of interest, no? NSP, it's an integer and we don't want that to be an integer. Although may mga iba pang variables dito na looks like classification din siya, but we'll just focus on the integer. Okay, so let's convert our NSP into a factor. All right. So data, oops, ano nangyari dito? Double data as factor NSP. No? Okay, so we're converting our NSP variable into a factor. Let's run this. And then tingnan natin guys yung distribution ng ng values yung 0, 1 and 1, 2 and 3 sa NSP. Let's see. All right. So here we can find that dun sa 2,166, 2,126 na observations, 1,655 were normal, 295 were suspect, and 176 were pathologic. Okay, so let's now do data partition. We use the index. Ito yung 3 and natin, 3 and train and test. Okay, of course you can use other forms of partitioning the data. You can use k-fold k-fold cross validation. Okay, but let's just use this simple splitting our data. Oo nga eh, parang I think we already encountered this data before. Let me just check sa natin, no? Sa modules natin. Ito yung guys, yung cardio. Ito yun, it's the same data, yung cardio natin. Okay, and we did decision tree na pala dito. Okay, so what you can do guys is to open in your own time, open nyo yung decision tree natin na to. Okay, and then compare nyo kung ano yung results using decision tree and using random forest. Okay, so all right. So mag-partition na tayo guys. Let's set that seed natin para pare-pareho tayo ng partitioning. Set that seed 1, 2, 3. And then let's create an index. Sample, we use a sample function. 2 groups. Row natin is the row of our data, which is 2, 21, 26. With replacement to, no? Kasi parang bootstrapping to. And then the probability will split it into 70 and 30. And then we create this object called train. So it's a subset from your data where the index is equal to 1 and all the columns. The number of rows, the rows are those which are indexed as 1. Yung test naman natin, index as 2. Okay, so let's run this. Run ko na yung set.seed, no? I'll run this next. Okay, so You should be having, guys, you should be having ilan ang ano nyo, ilan ang test data nyo? 631 ba? 631 ba yung test data nyo? Paki-chat naman please. 631 at saka 1495. Okay. 2126 kasi yung ano natin observations, no? And 70% yan is 1488. So hindi siya exact, no? 1495. As I mentioned last time, guys, I noticed that when your decision variable, when your variables contain yung mga characters, hindi siya nag-e-exacto. Pero pag numeric lahat, I noticed that nag-e-exact, no? Exact lahat, exact yung partitioning. But anyway, it's okay. Hindi naman siya masyadong problema. Okay? All right. So, we have the same data, no? Okay, if we take a look at, i-view natin si, ano, i-view natin si ind. View, yung index natin, let's view it. Okay, we can see here that 1, 2, 1, 2, 2, 1, 1, 2. Ito yung classification natin. Okay, and if you check, guys, your classification, it will be the same. Ibig sabihin, pareho time, we will have the same trained data and the same test data. Okay, clear so far, guys? Importante, guys, na pareho tayo, so that we get the same results. Otherwise, if we didn't set that seed, guys, since this is a random number generator, no? So magkakaiba tayo ng ano, magkakaiba tayo ng training at saka testing data set. Okay. So we're going to use the package random forest. Kindly tanggalin niyo lang tong ano dito, tong yan, tapos install nyo. I'm just putting there the hashtag kasi na-install ko na. Okay, so kindly install random forest and access the package, load the package. Ito. Okay, once you have installed the package and loaded it, same, the tables aren't viewing. Oo, Nick, ganun na naman, ano? Pero it's okay. It's okay. Aren't viewing rin po from the view. Ito na naman si Jan na naman, no? Hindi naman nakikita yung view. Hindi pa natin nare-resolve yan, ano? Pati kay Nick. Okay, but that's okay. Remember, Jan, ano yung ginawa natin kahapon? You recall, para malaman natin na talagang may ano, may object tayo na ind. How do you test, guys, kung andyan nga ba yung int na ano nga siya na run ni ano ni R? Of course not. No. Diyan ano ginawa natin kahapon para to be assured na ando doon nga yung ano nagawa nga yung int? Naalala mo yung ginawa natin kahapon? Nalimutan mo na kaagad. Okay. So, how sure are you na andyan nga yung ano, yung open nyo na yung train data. Sige. Open nyo yung train data. Let's compare the train data. Okay, yung train data nyo ba, ang mga observations natin, si number 1, 3, 6, 7, 9, 10. Okay, Nick at saka John, paki-check nga kung pareho tayo ng train data. Kasi if we have the same, then it means that nag-work yung ind nyo, yung index nyo. Kasi yung train data natin at yung test data is dependent on the index. Okay, kindly check now please and kindly chat kung yes, kung pareho tayo ng train data. Of course, yung 2, yung 4, yung 5, yung 8, nasa test data yan. Yan, yung 2, yung 4, yung 5, yung wala dun sa train data, nasa test data. Same, okay, same. Nick, thank you. John, ikaw, same. So, ibig sabihin niya, Nick, nag-work yung yung index. Hindi nga lang ma-view. Same kay John, up to now, hindi pa natin ma-resolve yan kung bakit. Yes. Okay, pero diyan i-check mo nga kung ano yung i-check mo yung i-view mo yung train data mo. I-access mo yung train. And you should have this. Click mo yung dito sa spreadsheet dito sa data mo. And then it will show this. And dapat yung index niya yung 1, 3, 6, 7, 9, 10. Okay. Yeah. Ano ba, John? 1, 3, 6, 7. Tingnan mo yung index numbers mo. One, 3, 6. Dapat yun ng numbers, no? Yeah. Okay, good. Okay, good. So ibig sabihin, gumana naman yung index nyo. Yun nga lang na hindi natin ma-view siya. Okay, so let's go back to our model. All right. So na-load na natin yung random forest. Again, guys, it's good practice always. Pwede nyo i-google siya, tapos pwede nyo always try to study the package first. So this was developed by Bryman and Cutler, random forest for classification and regression. Na-develop nila noong March 22, 2018. Okay, so sa CRAN, guys, makikita natin diyan yung description ng yung documentation ng random forest. But I leave that to you guys for your inspection, for your study. Okay? So ngayon, guys, gagawa na tayo ng random forest. Napakasimple lang ng coding ng random forest, except pag mag-tune na tayo mamaya, no? Ipa-fine-tune na natin yung model natin. Okay. So let's set that seed again para pare-pareho tayo ng random forest output. Set that seed. Let's create an object called RF, and we're using now the function random forest. Of course, this is from the random forest package. Okay. Ano nga natin? Random. Yan, random forest. So this is now the code, no? Click natin, enter. Okay. So ito, guys, ito yung code ng random forest. So there are many parameters here. Okay, andyan yung X, Y, X test, Y test, number of 3. Ito yung sinasabi natin kanina. Take note, ang default, guys, N3 is equal to 500. Okay, can you see this? Default yan. So pwede natin gawing mas mababa or pwede mas mataas. Then ito yung sinasabi kong M-try, Yung M-try natin. Yung M-try is the number of features or number of variables na magdedetermine ng isang node. Okay, and the default there is always, pag classification yung problem, malalaman naman kung classification kasi sa variable, no? NSP is a categorical variable, so this is a classification problem and not a regression problem. Okay, so ang i-default ni random forest dito is the square root of P. Okay, square root of P, ilan ba yung ano natin? Ilan ba yung variables natin? Our variables are 22, 21 ba? So square root of 22 or 21, that's around 4. So ang gagawin niya, yung m-try niya, ang default will be 4. Okay? So let's keep it simple. Let's just follow the, mamaya titingnan natin itong mga importance, yung proximity. Okay? We will try to include that in our model. Okay? Okay. Pero let's keep the defaults first. Let's just follow whatever the default here is. So random forest, NSP yung ano natin, yung dependent variable. Okay, regress on all the other variables and then use the data is equal to train data and then i-print natin si RF natin. Okay. So nagra-run na yan guys nagra-run na ng 500 trees yan, no? 500 decision trees. So while yung ano natin, yung what we learned before, isang decision tree lang yun, di ba? Ito, 500 decision trees ang ginagawa niya. So it's gonna take a little bit of time. Okay, tapos, no? So imagine creating 500 different trees. Okay, imagine guys, i-ano niyan. Gamitin natin yung decision tree model natin before na isang decision tree lang talaga yung nag-generate, no? Ito 500 and then kino-compute siya, ina-average lahat to come up with the aggregated model. So ito yung sinasabi natin, number of variables tried at each split, no? 4 variables tried at each split. So yung m-try natin, okay, ito yung entries natin. Default is 500. Yung 4 dito, sabi natin, it's a square root of your P, your features. Since ang variables natin is 21 ba or 22, square root of that is around 4 or 5. So naging default niya is 4. Okay, let's see the result. Okay, so we have here, okay, OOB estimate of error rate. Naalala niyo to, out of bag estimate of error rate. Ibig sabihin nun guys, yung mga out of bag natin, yung hindi nakasama dun sa bootstrap sample natin, yun ang tinest natin. Okay, and when we tested our model dun sa mga yung mga OOBs, yung mga out of the bag samples, guys, ang error rate natin is 5.62%, which means 94%, 95%, around 95% yung accuracy ng model natin. So okay, mataas guys. Mataas yung accuracy ng model natin. And in fact here in the confusion matrix, yan binigay sa atin, no? Confusion matrix 1, 2, 3. Di ba si 1 guys, ito si normal, suspect, and ito si si pathologic. Okay? So yung diagonals natin guys, yung diagonal natin, these are the correct predictions. No? So ang actual na na-predict na tama 1142 na normal, no? Yung S suspect predict 164, actually suspect nga siya, so tama ito. Okay? 3 natin, 3 pathologic. Okay, it was predicted to be pathologic when in fact it was really pathologic, so 105. Okay, so if we take a look at the classification error dito sa number 1, okay, ano yung error niya? 1.55% lang. So how did we get that? Paano natin nakuha itong 1.55%? So that's 18, ilan yung error niya? Ilan yung maling na predict? 18, ano? Divided by, isam natin si, hindi ko pa inad. Sana inad ko na lang. Oops. 1142 and 18. Nagsampa ako. Okay. Control and enter. So that's 1551, di ba yun? Okay. So as far as the normal data is concerned, okay, 1.55 yung mali niya na-predict. Sa number 2, dito medyo mataas, no? Ang error niya dito, okay, 23% sa number 2. Okay, paano naging 23% yun? Kasi ang tama niya, 164, ang mali, 47 and 2. So if we compute for that, Control C, ang tama niya, 164, then divided by, ano yun? 164 plus 49. Diba? 49 yung mali niya. Okay. Enter. So, tama niya, 76, no? So, ang mali, copying ko to. O, tama. 76 yung tama, around 77. So, ang wrong, guys, 23%. Okay? So, that's how we got the classification errors here. Okay, and then we see, guys, that medyo problema natin si number 2, no, sa pathology, sa suspect. Medyo dito mataas yung ano niya, yung mali, no. Sa number 1, okay yung ano niya, no. Mataas yung correct forecast niya. Pati sa number 3, relatively compared to number 2. So pag pinipredict nila yung pathologic, mukhang relatively okay naman compared to number 2. So dito sila nagkakaproblema sa number 2 kasi 23% yung error, no? Okay, then here I just made some notes here, yung out of bag error rate, ba? So there I gave here some notes, no? I gave here some notes about what OOB is. Pero sinabi ko na kanina, 'di ba? Ang OOB, guys, is just kasi ang random forest ang ginagamit niyan, bootstrapping. Okay, yung bootstrapping, guys, pag kukuha ng resample niyan, pag kukuha ng sample, it makes use of the with replacement, no? So ibig sabihin binabalik yung data, kinukuha ulit. So magbo-bootstrap ng several samples, okay? And then they will create a decision tree out of that, bootstrap na naman. So several bootstraps, no? To create several trees. In our case, there were 500 trees created. So 500 trees. Okay, so the resampling method used here is bootstrapping. Kaya meron tayong tinatawag na OOB, out of the bag. Kasi pag bootstrapping, di ba, we learned yesterday that on the average, around one-third ang hindi nasasama dun sa pag-sample. No? So yung hindi nasasama na yon sa training data, it forms part of your test data. Okay, and then when we model now based on the different bootstrap samples, when we model it now, nakakapag-create tayo ng we are able to determine ano yung errors, no, ng model natin based using the OOB, yung out of bag natin, yung hindi nasama dun sa bootstrap samples. Okay? Okay, as I said, guys, here, yung confusion matrix natin, 23% yung error for class 2. For class 3, 13.9%. Okay, so ano ba laman, guys, ang RF model? Let's see. Okay, so let's take a look at this. Yan, RF model. Ito yung mga attributes niya. Okay? So, ito, 19 elements, no? Call, type, predicted, error rate, okay? And we can call, we can access, ano ba yung mga laman ng mga to? For example, itong confusion. So si RF's random forest, meron siyang laman na confusion. Okay, so let's run this, guys. How can we access confusion? Ito lang, no? When you type RF, okay, RF and then dollar, okay, lalabas yung mga laman niya, no? Yan. Okay, yung iba, yan, spreadsheet, table, sheet, no? Confusion, error rate. Okay, let's first see, kunyari, confusion. Kunin natin si confusion. Then i-run natin to. So it will give us yung confusion kanina, yung confusion matrix. Okay, so let's look at another object here, RF. Okay, spreadsheet error rate, tingnan natin. Ano ba naman itong RF error rate? Okay. All right, so ito yung out of bag natin, no? Out of bag. So ilan yan? Okay, 500 yan, 500 trees, no? 500 yan, 500 out of bag error rate kasi there are 500 trees. So ang ibig sabihin yan, guys, okay, sa 3-1 ito, the out of bag error was around 11%, no? Tapos yung error niya sa pag-predict kay normal is 5%, error sa pag-predict kay suspect is 33%, error sa pag-predict kay pathologic is 23%. So this gives us the summary of all the trees, no? Lahat ng trees na dinevelop na model natin. So we can see here that the OOB ranges from 10%. So, okay, may mga 6%, may 5%, etc. So, hindi natin makikita lahat, no? Unless, tingnan natin, let me check, no? Kasi I don't know if we can view this. Can we view this? Let's see, view. Tapos RF. Okay, kung pwede natin ilagay sa, yan, tingnan natin, error rate. There. I haven't tried this, but let me see. Pwede, no? Yan. Pwede natin kasi spreadsheet siya, table siya. No? Okay, so ito yung OOB, out of the bag error. Okay, and then ito yung ano, these are the, ito yung breakdown ng error dun sa 1, sa 2, at saka sa 3. No? Okay, if you take a look at hanggang, ano to, hanggang 500, no? Ayan. So may iba mga 5%, okay, 5%, tapos may mga, so mostly 5% kung titignan nyo. Kaya nung ina-average out siya, guys, kasi may 10% din, no? May 9%. Ibig sabihin out of bag error rates, no? Okay, yung sa number 2, guys, malalaki, no? 33%. So sa baba, going down, number 2, 23%. So when you average this out, nung in-average yan, ito lumabas. No? Yung result, no? Ito yung lumabas. Yung result natin, which was, where is that? This one. Okay. 5.62. Ito yung average ng OOB, yung pinakita natin kanina. Average ng error dun sa number 1 is 1%. Tapos sa number 2 is 23%. Sa number 3 is 13%. Okay? Clear yun, guys? Clear? Paki-chat naman please kung clear tayo so far. Okay, thank you. Very good. Okay, let me just pause for, I'll just get water, guys. Okay. So where were we? We were looking at the RF object, and we can see that there are many elements of the RF object. Let's try one more. RF, and then, okay, votes, ano ba yung votes? Importance, let's see. Importance, let's run this. What can we find in importance? Ayan, okay. So take a look at this, guys. Okay, so this tells us about the importance of the data, of the variable, I mean. Mean decrease in Gini, okay? Yung Gini, guys, this is a measure of how important the variable is. We will not go into the details of this. This is not the same as the Gini coefficient in economics. Huh? This is something to do with Gini impurity. No? So this just tells us that as regards the importance of the data of the variable AC, mean decrease in Gini, okay? Impurity. Okay, these variables is MSTV 68. If we remove these variables, guys, magdi-decrease yung Gini. Okay, so it's important for us to understand ano ba yung Gini? What does that measure? Kasi if the Gini decreases, gumaganda ba yung model? Okay, because if the Gini decreases, guys, okay, if we want to decrease the Gini, okay, let me rephrase my statement. If Gini is a good measure, okay, if it will improve the accuracy of the model, then dapat hindi magdi-decrease yung Gini. No? So hindi dapat tatanggalin itong kunyari sa MSTV, ALTV, ASTV. If ever may tatanggalin na variable, dapat yung maliliit na maliliit na impact sa Gini. Itong DS, for example, kasi 0.2 lang siya, no? As compared to 68, 67 dito. Okay, so yun yung importance, guys. So we have to understand what the Gini means, no? Kasi if Gini is something positive, so we don't want the values here, with the high values here, like as I mentioned, MSTV, we don't want to remove these variables. Okay, so we'll discuss that later. So a lot of things we can see here. What about, guys, tingnan natin yung okay, so far ang tinitingnan natin yung mga yung mga may spreadsheet. Okay, votes. Okay, so ano kaya tong votes? No, I have not first time ko lang nakita tong votes na to. Okay, I have yet to see 33, 34, 31. Okay, they add to 100%. So I think these are probabilities, no? Okay, probability siya. So for sample number 1, okay, kasi di ba ito yung mga samples natin 1, 3, 6. Okay, lahat to 1495 lahat to, no? Okay, now we know. Ano yung votes na to? These are the probabilities. So all in all, 465 plus 1162 omitted rows, so that's 1495. Okay, so the votes here are the probabilities of predicting whether it's 1, 2, or 3. Okay, kaya ito, guys, si sample number 1, okay, based on the model, this should be N kasi 34% to eh. Tapos si number 3, this should be S, no? Number 2 is S. Number 3, 98% 1 ang probability niya, so this should be N. Okay, this is also N. This is P. So kung sino, guys, mas mataas na probability, yun yung lagyan natin dito para probabilities of predicting N, S, or P, which is just 1, 2, or 3. Okay. So this is the Gini importance. No? Okay, so let's leave that, guys. We haven't one more RF. Now, what happens if we try, kunyari, ano tong predicted na to? Let's see. Okay, so ano siya, no? Ito na, guys, yung ano, yung prediction, no? Okay, 2, 1, 3, 3, 3. Okay, recall this, guys, 2, 1, 3, 3, 3. Okay, if we run this, yung votes, no? Take note, 2, 1, 3, 3, 3. If we run the votes again, yung probabilities, di ba? Okay, ito, guys, ano yung predicted dito? So 2, kasi pinakamataas yung probability, di ba? 2 tapos 1 tapos 3, 3, 3. Okay, tama, no? 2, 1, 3, 3, 3. Okay, so let me just put here predicted values for the observations. Okay. All right, so let's close this. Okay, so let's now go, guys, let's now create a confusion matrix. Although may confusion matrix na to, di ba, yung random forest natin, may confusion matrix na siya. Kaso, let's create now a confusion matrix making use of the okay, ito, prediction natin. Let's create an object called P1, and P1 will use the predict function. Okay, we're going to use the RF model, yung random forest model natin, on the trained data set. So let's run this. So mag-create tayo ng predicted values using the random forest for train, and then let's get the first 10 of P1, and let's put it side by side with the actual value, yung train data set natin, and then yung variable na NSP. So let's run this. Okay, let's see, guys. So ito yung predicted values natin, 2, 1, 3, 3, 3, 3, 2, 2, 1. And these are the actual values naman. Ito yung head natin ng P1. Okay, first 10 values. Ito naman yung head natin ng train data natin, yung NSP. Okay, so when we compare this 2 with 2, 1 with 1, 3 with 3, okay, mukhang okay, 2, 1. Okay, yung first 10 elements, guys, perfect. Tama lahat, no? Ito yung prediction, and then ito yung actual values. Okay, so we were putting side by side here the predicted value, and then the actual value, yung from the trained data set, yung NSP. Okay, pause muna ako, guys. Any questions here? So kaya 95% kasi yung di ba? Yung accuracy ng prediction natin, kasi yung OOB natin, yung out of bag error term is around 5-point-something%. Any questions, guys? So clear ba tong na to, yung kinompare natin? Ito, guys, this is the observation number 1, 3, 6, 7. Iba yung train data set natin. 1,495 observations. Ito yung mga index niya, 1, 3, 6, 7. Tapos ito yung predicted value niya based on based on our RF model. And then we are comparing it with the actual values. Yung train data set natin, yung NSP variable. Okay, clear so far, guys? Paki-chat naman, please. Okay. John, kamusta? Nakakahabol ba? Okay, thank you. Thank you, guys. All right. So, install natin, guys, si Caret, 'di ba? Ginamit natin 'to kahapon sa cross validation. Tapos sa sa paggamit ng ng confusion matrix. Okay? Let's generate the confusion matrix, guys. using our caret package. Okay, so i-require lang natin. No need for you to install kasi. And I just have here some notes kasi minsan there are difficulties in installing the caret package. So pwedeng ito yung gagawin, no? Let's not run that. Okay. So once you have loaded the caret package, let's now use the confusion matrix from the caret package, and i-compare natin si B1, okay, P1 guys. Ito yung predicted value natin, di ba? P1 is the predicted value, and then yung actual data natin, yung train NSP. So let's run this. Okay, di ba sabi natin maganda yung sa caret package sa confusion matrix kasi it gives us several measures. Okay, so ito yung confusion matrix na na-generate based on the predicted value coming from the RF model and then the train and the NSP. Okay, so if you take a look at this guys, ang taas ng ng accuracy, no? Okay, so this is 1160, 211, 122. And then here we have a table. So 2 lang guys yung misclassified, no? So that's 2 out of the total 1495. So that's 1493 divided by 1495. Okay. Correct predictions 99866 and 9987. Okay. Then we have here the confidence interval, 95% confidence interval. Okay, then ano tong no information rate natin, guys? We studied this yesterday. And then ito na naman si kappa. Okay, very high yung kappa, no, 99%. And then you have here the predictions, the measures, no? Statistics by class, yung sensitivity, specificity. Okay, and then the positive predicted value, the negative predicted value, prevalence, detection rate. I gave you some reference yesterday, guys, kung paano i-compute to, no? So I hope, guys, you were able to compute for that, or you were able to read through that. Kung hindi pa, basahin nyo. Tapos you try to compute kung tama nga ba yung pag-compute, no? Okay, so let's go here. Ano yung no information rate, guys? Paano natin mina-measure no information rate? Yung 77.59. Di ba meron tayo dito ng table kanina? Table, let's run that again. Table ng data natin. Table ng train data natin, and then NSP. Let's see. Okay. 1160 yung normal, 213 yung ito yung actual data, no? 213 yung suspect, and 122 yung pathologic. So if we're not going to use the random forest, okay? So brute force lang na prediction. I-predict na lang natin lahat na lahat na normal. Okay, and what are our chances na tama yung natin? 1160. Let's get the proportion of the correct. And then 1160 plus 213 plus 122. Okay, so what we're saying here is, yung ibig sabihin ng no information rate, we're not going to use the random forest model. Let's just get the distribution among the normal, pathologic, and suspect, and just choose the biggest frequency, itong 1160. And then we just predict everything to be normal. Okay, so what will be our rate, correct prediction? So that's 77.59. Yun, guys. No? 77.59. So what's our decision, guys? If our model is not able to give us, okay, a high higher accuracy compared to your no information rate, there's no sense in creating the model, ba? Ito mataas yung accuracy rate natin na 99.87. Tapos yung no information rate natin 77% lang. Okay, so this is very high, no? Now, because we're using the trained data, okay, now I'd like you to discover bakit iba tong 99.87 kaysa dito sa unang RF natin. No? Yung RF natin na generate kanina, ito, this one, the accuracy was only around 94.4%. No? Okay, kasi may error rate tayo dun sa OOB. So what's the difference between this one and the one that we created through our confusion matrix via yung caret? So what's the difference? Okay, so I want you to think about that and discover ano ba yung difference ng 99.87% na accuracy natin dito sa confusion matrix natin dito using the caret package. Okay, pareho lang naman yun, di ba? Confusion matrix ng P1 natin. Ang P1 natin, what's our P1 is we're predicting, di ba? Take a look at this, di ba? P1 is predicting using the random forest model, okay, and then the trained data, right? So ano naging difference yan? As I said, guys, bakit dito? Why here? It's the accuracy is 94.4%. Doon naman 99. Halos perfect na 99 kasi dalawa lang, guys, di ba? Dalawa lang yung misclassified, no? Only 2 out of the total 1495 observations. So I want you to figure that out, no? Okay, then going here, sensitivity. How do we compute for sensitivity? How do we compute for that? So, di ba tinitingnan natin dito yung true positive niya, okay, is 1160. Tapos ito yung mga false negative siya, no? So 110 divided by, wala siyang errors, divide by 110, so that's 100%. Sensitivity for number 2, 211 over 2. Sensitivity for number 3, 122 over 122 kasi walang mali, no? So ang sensitivity natin for class 2, 99% lang. Okay, dito naman 100%. Okay, how about specificity? Ano yung, paano natin may measure yung specificity? How do you measure that? Yung 99.4%. Okay, how is that measured, guys? Dito yon, no? Dito siya. So 1160 divided by 1160 plus 2. Kasi may dalawang error siya dito. So we're taking a look at the, this is your true positive, di ba? And this is your false positive, another false positive. So dalawa yung false, isa lang yung false positive natin dito yung kulang. False positive din to, kaso 0 siya. No? Hindi siya mali dito. Okay, so let's just check 1160 divided by 1160. 99.82. Okay, ang specificity for number 2 is 100% kasi wala siyang mali. Also for number 3. For number 1 lang may error 99.83. 99. Yan, 99.4. And then sorry guys, 99.4. I think I got the wrong specificity, no? Specificity natin is 99.4. Okay, I think I have to refer back to the formula, no? Yung sa formula ng specificity. Okay, but anyway, guys, I leave that to you for your exercise. I forget the formula for specificity. 99.4, that should be 1160. Tama ba ako? Divided by 1162. Tama. May mali na 1162. Specificity for 1 is 1160. Okay. Okay, anyway, sige. I-ano na lang natin. Leave that for a while. No? Okay, so let's go now to, so far what we did was to check our data, our RF data, random forest data on the trained data set. Now what we do is, of course, to test this on the test data set. Okay, yung data na hindi pa nakikita ni random forest natin. And there are 631 observations, no? 22 variables. Okay, so let's see. Okay, so predict natin guys si RF using RF for the test data set. No? And then let's create the confusion matrix using the test data again. Hindi pwede yung train guys kasi magkaka-error tayo sa confusion. Kailangan pareho yung number of rows ng predicted natin at saka ng actual natin. Okay, let's run this. Okay, so here we go guys. Okay, so for the test data set, ito yung mga correct natin, no? 482, 61, and 46. Okay, so that's an accuracy of 93.34%. Okay, let's check the accuracy. That's the sum of 482 and then 61, mga tama, no? And then 46. Okay, divided by the total is, diba, total 631. So that's the number of the correct predictions divided by the total of 631. That gives us, enter, 93.34. So that's it, guys. 93.34. Okay, so tapos ang no information rate natin. Again, guys, we can create a table for this. Table, and then it's coming from our test data, yung NSP natin. Okay, table. So we're asking R to tabulate yung mga different distribution ng, so that's 495 yung 1, 82 yung 2, 54 yung 3. So if we're going to make use of 495 only to be our forecast value divided by 631 lahat. Okay, diba? So this is the no information rate that gives us 78.45. Okay, 78.45. So the accuracy, if we are using the RF random forest model, is 93.34%. That's a lot higher than not using anything at all, no information rate natin. So 78.45%. So okay yung random forest natin. Okay, so meron na naman tayo dito yung sensitivity, specificity, positive predicted values, negative predicted values, etc. Okay. All right. So what we're going to do now is we're going to see yung error rate ng random forest natin. So let's first plot our random forest. No? Plot natin siya. Okay, plot natin. And okay, you can see here guys yung error rate tsaka yung number of trees. Ito yung entries. Let me increase the size. Okay. So what's this, guys? What are these? So you can see here on the x-axis is your number of trees. On the y-axis is your error. And notice, simula, no? Pag 1 tree lang yan, okay? You can see here the fast decrease of your error rates. So the more trees we add, the better our model is because the less errors you have. Okay, until such point na, okay, when you go here, so kunyari sa 200 trees, well, it still goes down, bumababa pa rin, no? Pero pagdating dito sa 300, okay, wala na, no? So there seems to be no more decrease in your error percentage at 300. So ang lesson dito guys, even if we increase the trees, kahit gawin pa natin 1,000 yan, okay, even if we make it 1,000, wala nang value added yun kasi your error terms your error predictions, error percentage is no longer decreasing. Parang nag-plateau na siya dito sa maybe around 300. So that's what this is telling us. So we can fine-tune our model. Okay, we can fine-tune our model so that hindi na 500 trees yung, which is the default, no? Di ba yung 500 trees is the default? So pwede natin sigurong bawasan yung number of trees natin. Okay, kasi adding more trees, let's say you make it 1,000, okay? Hindi naman madadagdagan yung hindi naman madadagdagan yung accuracy ng model natin. Okay? Clear yun so far, guys? Okay, so as I said here, no improvement seems to be seen after 300 trees. So we can tune now our RF model. Gawin natin itong small, para hindi kayo malito, RF. Okay, because that's the name we gave our random forest model. We can now tune our random forest model. Okay. So what do we, so ito guys, yung train natin, all the rows, okay, except for the dependent variable. Okay, ito naman guys, itong subset na to, train only the dependent variable. Okay, and then we're going to create an object now called T. Tapos i-tune natin yung RF natin. So this is the function. Okay. So we have here, may mga parameters dito. It's always best guys to natin tune RF, tune our random forest. This is the function to improve our random forest. Okay, let's wait. Okay, ito tune RF. So this is from our random forest. Okay, so ito yung natin, ito yung function niya, x. So what's your x variable? And ang ginagamit natin ng x guys na variable natin yung mga independent variables natin, yung mga predictors natin. Our y is our dependent variable. Okay, m try start. Okay, kung gusto mo saan magsisimula yung m try. And then n3 try. Mga mga default to, 50. Step factor. Yung step factor guys, how much inflation of m try for each iteration. Ibig sabihin, it will keep on increasing your m try. Pwedeng 1 each, 2 each. Okay, di ba kunyari ang m try natin yung number of variables na ginagamit sa node. Kung 4 yan, pwedeng m try natin gawin mong 5, 6, 7. Mag-i-increase siya, mag-i-increment siya ng 1 each. Kung ang m try mo, kung ang step factor mo is 1. If your step factor is 2, ibig sabihin mag-i-increase ng 2 yung m try natin. So this is the default, 2. And then, okay. All right. So dito ang ginawa natin, n try natin, n3 natin, ginawa natin 300. Plot is equal to true. Okay, yung trace naman, whether to print the progress of the search. Okay, so ipiprint na yung progress of the search of the trace, and then improve. Improvement in OOB error must be by this much for the search to continue. So sinasabi natin dito, kung nag-i-improve ba yung OOB ng 5%, no? 0.05, then ituloy pa rin niya yung search. Okay. So ito na guys yung function natin, tune RF. Rx is our trained data, wag not except for 22. So hindi natin isasama dito yung si NSP. Kaya nga natin linagay na negative 22. Our Y data naman, our Y is trained data then and then 22. No? So this is the 22nd variable. This is your NSP. Step factor natin, gawin natin kunyari 1. No? 1 muna. And then plot is equal to 2, true, and try natin, nakita natin kanina, di ba? So gawin natin 300 na lang. tapos trace, and then improve. So let's run this. Okay, ano lumabas dito? Okay, mukhang walang lumabas ano, sa mtry kasi one lang yung increment natin. Baguhin natin increment. No? Okay, walang lumalabas pag 1 lang yung increment. So yung mtry natin gawin nating liitan natin, no? Where's our mtry? Step factor natin, gawin natin, liitan natin 0.5. Let's see what happens. Let's make this 0.5. So let's run this. Okay, yan. Yan. All right. Okay. Yan. So what do we find here, guys? Okay. So dito, mtry is equal to 4. OOB natin yung kanina to, yung 5.89. Then ginawa niya mtry is equal to 8. No? mtry is equal to 8. OOB became 5.48%. Tapos mtry is equal to 16. OOB error naging 5.42. mtry is equal to 2. So ang ginagawa niya, guys, nag-ano siya, no? Nag-iterate siya, trying to find out which of the combinations of mtry will yield the best result where OOB is minimum. Okay, tingnan natin, guys, dito, no? So it looks like dito it looks like ang minimum natin na OOB is at 16. mtry pala, no? What did you get, guys? What did you get? mtry nyo ba 8 or 16? Funny, guys, kanina ginawa ko to, no? And then yung mtry natin, yung OOB error umakyat, no? Nung nag-16. Dito I'm getting a different result. Okay, what's your result, guys? Ayun nga, Nick, thank you. That's what happened a while ago sa akin kanina, no? I'm wondering why it went down to 16. Okay, so that's what I got a while ago when I was running this. So when it came to 16, tumaas siya. Okay, so let's just use the result of your model. I don't know why ano nangyari dito sa model ko. So let's assume that the mtry should be 8, no? Kasi yun nagbibigay sa atin ng minimum na OOB error, no? Out of bag error. Okay, ito nga sabi ko, nilagay ko, guys, no? That at mtry is equal to 8, the OOB error is minimized and goes up again if mtry is equal to 16. So now I'm wondering why it did not result to that. Okay, so balikan natin, guys, yung ano. Balikan natin yung ano natin. Yung random forest natin, no? So we're creating another RF. Okay? Okay, if you want, you can make this RF1 to preserve yung unang RF natin. So random forest naman tayo ulit, NSP. Ang dependent variable natin regressed on all the features. Data is equal to train. Then linimit na natin, guys, yung entry natin, 300 na. mtry is equal to 8. Okay? Importance is equal to true. Proximity is equal to true. Ito yung kanina mga nasa random forest, no? And then you can just take a look at what does importance is equal to true give us. Proximity then, and then i-print natin tanggalin natin itong attributes. Okay. Then let's print now the RF, no? Yung bagong RF natin. Na entry natin 300, mtry natin 8 na ngayon. Kanina yung mtry natin is 4, no? Yung default. Kasi square root of 22 yun. Square root of 22 is around 4. All right, so let's run this. Run. Okay, let's see. All right, 5.28% yung OOB estimate rate natin. How does that compare to what we did a while ago? Ano yung OOB ano natin dito? Let me see. Okay, 5.62, no? 5.62. Tapos, 0.23, 0.13. Let's see, compare natin. So, sa bagong model natin, okay, nag-improve siya, di ba? So from 5.62 yung OOB estimate natin ng error, naging 5.28 na lang. Okay, and then there was also a marginal marginal improvement in predicting your yung 1, 2 and 3, no? Lalo na yung 2 kasi kanina 23% yung error nito eh. Tapos 13% yata yung error nitong 3, bumaba siya, no? Okay, so number of trees natin 300, tapos yung M prime natin, yung number of variables tried at each split is 8. Okay? So you now have a better random forest, no? Gumanda yung OOB estimate error natin, bumaba. Tapos yung particularly yung confusion matrix natin, dati 23% to kanina. Ito ngayon 21 na lang, tapos ito 13% kanina, naging 9% na lang. Okay? So let's now use okay, let's again predict, guys, using yung train data for the new RF na to, no? New RF, run natin to. Okay, new RF. No information rate natin, 77.59 pa rin talaga yun. Accuracy, 99.87. So, nag-improve ba siya? Pareho pa rin, ano? Hindi masyado. No? Not much difference. Okay, but what's the test here, guys, is sa ano na natin, sa test data natin. Okay, kasi nakita na tong ano, no? Nakita na tong train data kanina. So when we tried to run it dun sa ano sa bagong RF natin, wala masyadong difference kasi yun pa rin naman yun eh. Hindi naman nagbago yung train data natin. But now we're going to test the RF, the new RF sa test data. Yung bagong RF natin, hindi pa nakikita yung test data natin. So let's see. Let's see what happens. Okay, nagbago ba, guys? Yung ano? Okay, accuracy natin 93.5%. A while ago, what was our accuracy? Dun sa test natin. So sa test natin is ito. Ito yung test natin, ano? 93.34%. Okay. There was a little improvement kasi 93.5 na tayo ngayon. Kappa is 81.09. Let's see. Okay. Nag-improve, guys, yung overall accuracy natin. Nag-improve yung kappa natin. Okay. So the new model is a better model in predicting yung test data natin. Okay. In fact, guys, dito, sensitivity natin, ano nangyari dito? 0.96. Ito 75%. Tingnan natin yung sa test natin yung una. 75. Ito 74, no? So there was a marginal improvement as far as predicting the second class number 2 is concerned. Okay. So may improvement naman, guys, when we use the new RF model, the random forest model. Okay. So lastly, guys, let's do some i-check lang natin yung mga nodes natin. We can create a histogram for our yung tree size natin ng yung bagong random forest natin. We can give it a name, number of nodes for the trees, and we can give it a color. Let's run this. Okay. All right. So what does this tell us? Okay. So dun sa ano natin, sa model natin na random forest, karamihan ng mga trees doon, guys, karamihan ng mga trees, ito, okay, number of nodes for the trees, di ba? So this is the tree size. So marami doon sa mga trees natin, itong mga more than 80. Okay? Ang tree size niya, mga 80. No? konti lang yung tree size na more than 100, konti lang din yung more than less than 60. So most of the trees, guys, 80. Okay, so that's what that means. No? So highest seems to be at 80 trees, which contain around 80 nodes in them. Few trees have 60 nodes, and much fewer trees that have 100 nodes or more. Okay, so in other words, guys, kung titingnan natin yung random tree, yung trees natin, marami doon, guys, 80 yung mga nodes niya. Imagine, guys, a decision tree having all in all 80 nodes. Okay, so karamihan daw ng mga dun sa trees natin, most of them have 80 nodes. There were only a few that had more than 100 nodes or less than 60 nodes. So in concentration ng random ng mga trees natin, yung mga decision trees, yung mga nodes niya ranging from 70, 80, okay, 70 to 80 to 85. Doon ang maraming ang concentration ng mga trees natin, ganun yung dami ng nila, ng mga nodes. Okay, then this is what I mentioned a while ago, yung variable importance. Okay, so which of the variables that we use in predicting our NSP is most important? So let's run this. Ito. No? So dalawang measures dito, yung accuracy at saka yung Gini. Okay. So remember, guys, kanina nag-importance tayo. Okay, so it means, guys, that mean decrease accuracy. Pag tinanggal natin si ASTV, malaki yung increase, average decrease sa accuracy. Okay, so it means yung DS variable na to halos walang impact to, no? Okay, if there's one variable that we will remove, it's DS. Kasi even if you remove this, the accuracy will not change. Just very small lang, maybe less than 1%. Pero pag ang tinanggal natin si ASTV, guys, okay, accuracy will on the average decrease by 40%. So malaki i-decrease ng ng model natin. Pag tinanggal natin si ASTV, ALTV, etc. Okay? Okay, and then dito naman, yung Gini, guys, ganun din. This is another measure, but it's the same thing. Okay, mean decrease in Gini. Okay, pag si ASTV and MSTV, they seem to be the most important ones. In terms of accuracy, si ASTV. In terms of Gini, si accuracy, si ASTV din. No? In terms of Gini, si ASTV din. So very consistent si ASTV. Okay, so this tells us, guys, kung ano yung mga important variables sa model natin. Okay, and then just this last, no? Tells us how worse the model performs without each variable. Okay, tells us how pure the nodes are at the end of the tree without the variable. Okay, so last, guys, defining only the top 10 important features. So let's create this variable importance plot. Yung model natin is RF. Isort natin true. Number of variables is 10. Lagyan natin ng title. Top 10 variable importance. Kasi 21 yung natin eh. 21 yung predictors natin. Let's see. Okay. So here. Yan. So ito na yung top 10 na lang. Top 10 very important in terms of accuracy. Si ASTV, ALTV, etc. Tapos top 10 na lang in terms of Gini naman. Okay. Okay. So pwede rin naman yan, guys, quantitative presentation. So round off natin yung importance ng RF into 4 decimal places. Okay, so let's see. Let's run this. All right. Here you have now. Ito yung mga variables natin. Okay. LB. Okay, in terms of impact niya sa 1, sa 2, sa 3. So mean decrease in accuracy, ito is ASTV, no? Parang hindi siya na-sort. Okay, so ito yung kanina, 40, 29, etc. So this is just a table, 4 decimal places. Okay. So, all right, then okay, itong okay, itong partial plot, guys. Partial plot no ng RF natin on the trained data set ASTV1. So let's do this. Okay. So what does this tell us? Ano yung sinasabi nito? One, ano ba yung one natin dito, guys? Okay, once again, guys, if you have question about a particular function, it's always good to use this. Ito na natin ilagay sa console natin. Partial plot. Okay, partial dependence plot, okay, gives a graphical depiction of the marginal effect of a variable on the class. Okay, kaya tatlong class yan, ano? 1, 2, 3. So this one, 1, 2, and 3. So sinasabi dito, guys, ano daw yung effect, marginal effect ng variable na to on the class. Okay, so this is the syntax. Okay, so partial effect, RF, train, ASTV, and then 1, 3, and 2, 1, 2, and 3. Okay, run na lang natin to, guys. Okay. So this is the partial effect on 1. So what does this tell us, guys? What is the y-axis here? And what is the x-axis here? Okay, what does this tell us? O, kunyari, yung una, no? When ASTV is less than 60, it tends to predict that class 1, it tends to predict class 1 compared to when ASTV is greater than 60. Okay, tingnan nyo to, no? Okay, so 60 seems to be a cut-off point here. So ang sinasabi dito, pag si ASTV daw is 60 or less than 60, mas maganda, mas kayang i-predict si 1 kaysa kung ASTV is greater than 60. Okay, so that's what this tells us, no? Yung importance ng isang variable sa isang classification. So pag ASTV is less than 60, mas kaya niyang i-predict si class 1 as compared to when ASTV is greater than 60. Ibig sabihin, mas nag-e-error siya in classifying class 1 if ASTV is somewhere between 60 to 80. Okay, so ganun din, guys, yung number 2. Ito si number 3, no? Okay, so what does this tell us? Mas na-predict ni ASTV, guys, si class 3 when its ASTV is around pag greater than ano siya, no? Pag greater than 60. Pag greater than siguro 70 or greater than 75. So greater than 75, mas kaya niyang i-predict si class 3. And then lastly, this one, si number 2. Yun. Ito, guys, medyo erratic, ano? Hindi natin, we cannot make conclusions about this, no? So much. Kasi hindi siya, it goes down here. Ibig sabihin, pag yung ASTV is less than 40, medyo hindi maganda yung prediction niya. Pero tataas siya between 40 and 60. Medyo gaganda yung dependence ng class na to sa ASTV. And then, bababa na naman. So it seems like it's difficult to classify, no? To interpret for number 2. Tendency to predict it as 2 when ASTV is less than 40. Sabi natin, hindi maganda, no? Okay, hindi maganda yung prediction dito. Okay, dito maganda-ganda pero bumababa siya. So unlike yung iba, guys, medyo clear yung natin, yung functionality ng variable on the class, on predicting the class. Katulad nito, guys, less than 60, okay siya, mataas yung ano yung dependence, no? Pero sa number 2 on class 2 medyo it's quite difficult to interpret. Okay? All right, so ito naman get 3 guys. Okay? So ito guys yung 3, no? Ito yung 3 natin. Okay, 161, okay. So what does this mean? This in a table describes yung ano yung ano natin. Okay, so split variable ASTV, you have a left and right. Ibig sabihin, yung unang-una ASTV, then i-split siya into a left and to a right. Tapos titingnan sa next ano natin, sa next node titingnan si median. Okay? And then it will again split into a 4 and a 5. Okay, so ano lang to, no? It's just a depiction of how the tree, guys, how the tree is plotted. Okay, all right. So, okay. Tapos ito last na yung multidimensional scaling plot, MDS. Okay. So anong interpretation ito? Anong interpretation ito, guys? Okay, so I leave this to you, MDS, kasi kailangan mo natin i-discuss sana yung MDS, no? Okay, so and we have to identify ano ba yung dimension 1 at saka dimension 2 natin. Okay, so let's just skip this for a while. Okay, I'll just explain that when we go to i-discuss natin ng konti muna yung MDS, yung multidimensional scaling plot ng proximity matrix na to. Okay, with that guys, let's end our discussion for today. I hope you learned something. Thank you so much guys. So 9.5 hours, okay na, 1.5 hours tayo. So I'll post also this video to our oo nga, no, Nick, thank you so much for asking. Hindi ko pa na-post talaga, no, kasi I'm still medyo nag-aano pa rin ako, nagsa-struggle pa rin ako kung isasama ko ba yung mga kasama ngayon. But I'll do that, guys. I'll do that kasi wala pa tayong quiz, no? Yun ang concern ko kasi sa lahat ng subjects ko, tayo na lang walang quiz. So it will be more on projects. So I'm thinking na lang na yung unang quiz natin dito will be I'll give you a data and then you work on that using decision tree, using logistic, decision tree, at saka yung random forest. Okay? Thank you for asking, Nick. I'll make sure that will be already given. Hopefully by, kung hindi pa pwedeng this weekend, kasi gusto ko at least next week may masubmit kayo sa akin na first quiz. Okay, Nick, thank you so much for your question. I hope that answered your question. Okay, guys. So, salamat, guys. Thank you so much. I'll see you again on Tuesday for our continuation. Okay, we'll have another topic or maybe another example of random forest before we go to other methods like support vector machines and also yung mga XGBoost na modeling. Okay. Thank you. Let me stop recording now.